Yo, 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 what's going on, folks? About to hit you with another one real quick, man. You know, if you ain't heard by now, it's supposedly we got some aliens coming towards us. Yeah, we got some aliens coming towards us, man. They calling this thing that's moving out there 3-eye atlas or something like that. You know what I'm saying? But what we want to do is, while they think we ain't paying attention, we want to pay attention. You know what I'm saying? So, Black Anonymous, I'm here for you. You know what I'm talking about? I'm here for you. So let's go ahead and get to it.
Breaking news tonight as quantum AI scans have confirmed that interstellar object 3I/Atlas is not natural at all.
A bizarre, emerald-glowing traveler from another star system is zooming through our cosmic neighborhood right now, but Earth's telescopes are helplessly blinded by the sun. As NASA websites flicker offline during a government shutdown, this mysterious object named 3I/Atlas blazes past.
That's perfect timing, right? It's coming through some place where we're supposed to be trying to look at it, and it's a government shutdown. That's what they're trying to say to us? Damn it, the government shutdown is preventing something from. Come on now. Come
Mars
on now.
at a blistering 60 kilometers per second, breaking every rule in the comet physics book. Only Mars orbiters can witness its strange anti-tail and pulsing green shell. What is this interstellar visitor really made of? And why does it seem completely immune to solar storms that would shred normal comets? The cosmic irony of 3I/Atlas, an interstellar visitor observed from Mars. The universe presented an extraordinary paradox when 3I/Atlas, the third,
Yeah, I don't know what that is, but you can definitely see something moving right there. And I see everything else is still. So I don't know what that's shooting at, but yeah, that's moving pretty fast.
confirmed interstellar object made its closest approach to our solar system during a period when Earth's astronomical infrastructure faced unprecedented challenges. While terrestrial observatories remained shuttered due to solar positioning and governmental disruptions, Mars became humanity's sole vantage point for witnessing this remarkable celestial encounter. This emerald-glowing wanderer from beyond our solar system approached Mars at a distance of 30 million kilometers on October 3rd, 2025, creating a unique.
That was just 8 days ago, folks. Today is October the 11th, 2025. 8 days ago when this happened.
Observational opportunity. The geometric alignment of celestial bodies positioned Earth in an impossible situation for direct observation, as the sun's overwhelming brightness created a protective shield around the approaching visitor. Meanwhile, the red planet's orbital position provided an unobstructed window into deep space, transforming Mars into an unprecedented astronomical observatory. The observational blackout from Earth's perspective. Terrestrial astronomy faced an insurmountable challenge as 3I/Atlas approached its point of closest passage. The angular separation between the Sun and the interstellar visitor diminished to less than 10 degrees, creating what astronomers term a solar conjunction event. This geometric configuration rendered ground-based telescopes essentially useless, as the risk of solar damage to sensitive instruments.
It's just crazy how they got words and definitions and all this for all this is going on already. It's just the smart folks in this world, folks.
Forced observatories to implement strict safety protocols. The elongation angle, representing the apparent angular distance between the Sun and the target object as viewed from Earth, compressed dramatically during late September and extended through early November.
This game, you're not ready for it.
Observatories typically refuse to operate when targets approach within 15 degrees of solar position, establishing a safety margin that protects expensive equipment from catastrophic damage. The interstellar visitor's trajectory placed it well within this forbidden zone for approximately 6 weeks. This extended period of observational darkness meant that Earth's most sophisticated telescopes, including space-based instruments and advanced ground facilities, remained effectively blind during the most critical phase of the encounter. The timing created an unprecedented situation where humanity's primary astronomical resources were unavailable precisely when they were most needed to study this rare interstellar visitor. Mars as the solar system's watchtower. The orbital mechanics of Mars provided a dramatically different perspective during this crucial period. The red planet's position in its elliptical path around the Sun created an angular separation of more than 40 degrees from the interstellar object, often exceeding 50 degrees during optimal viewing periods. This geometric advantage transformed Mars from a secondary observational platform into the primary witness of cosmic events. Mars-based spacecraft, both in orbit and on the surface, possessed an unobstructed view of the approaching visitor throughout its closest approach phase, while Earth...
Man, we gotta find out what this is now. What's going on, folks? Is it aliens? Are the aliens coming? I mean, you can tell me now. I can take it.
Remained trapped behind the sun's glare, Martian assets enjoyed front row seats to observe any changes, outbursts, or anomalous behavior exhibited by 3I/Atlas during its transit through the inner solar system. The significance of this positional advantage cannot be overstated. For this brief temporal window, Mars effectively became the solar system's sole astronomical observatory capable of continuous monitoring. Every orbital pass of Mars-based spacecraft represented a precious opportunity to gather data that would otherwise be permanently lost to scientific inquiry. The International Fleet of Mars Observers. Multiple space agencies contributed to the observational campaign through their various Mars missions, each bringing unique capabilities and perspectives to the scientific endeavor. The European Space Agency deployed two primary assets, Mars Express and the ExoMars Trace Gas Orbiter, both equipped with sophisticated imaging and spectroscopic instruments. Mars Express utilized its high-resolution stereo camera alongside the Omega spectrometer to capture detailed multispectral imagery spanning visible through infrared wavelengths. These instruments enabled comprehensive analysis of the visitor's chemical composition and structural characteristics. The spacecraft's ability to pivot away from its primary Mars-focused mission demonstrated the flexibility required for rapid response.
Had to speed them up just a little bit for y'all folks, you know what I'm saying?
Astronomical observations. The ExoMars Trace Gas Orbiter contributed advanced spectroscopic capabilities through its NOMAD and ACS instruments, which dissected incoming light into thousands of individual wavelength components. This detailed spectral analysis searched for rare gaseous components and molecular signatures that could reveal the object's composition and origin. Both European spacecraft balanced their comet observations against thermal and operational safety constraints while maintaining their primary mission parameters. The United Arab Emirates Hope Orbiter brought a different observational perspective through its 11th camera and EMUS ultraviolet spectrometer. Originally designed for Martian atmospheric studies, these instruments proved adaptable for monitoring bright celestial objects within the Martian sky. Hope
It's crazy amount of equipment that we got out there to just observe, you know, what's going on. It's crazy, man. But we don't know if them aliens or not. You know what I'm saying? So we got to get our game. We got to up our game.
Global orbital configuration and flexible pointing capabilities made it particularly suitable for wide-field imaging campaigns and ultraviolet spectral analysis. China's Tianwen-1 mission possessed both high and medium-resolution imaging capabilities alongside mineralogical spectroscopic instruments that could potentially provide
Imagine bringing your side project to life.
Textual imagery, and near-infrared spectral data. The mission's contribution to the observational campaign awaited official confirmation, though its technical capabilities were well suited for such observations. NASA's Mars Reconnaissance Orbiter, equipped with the HiRISE camera and CRISM spectrometer, maintained a proven track record of conducting comet and asteroid observation campaigns. The spacecraft's participation in emergency retargeting operations depended on pre-approved operational plans and stringent spacecraft safety protocol. However, the concurrent United States government shutdown complicated public access to any collected data, even as internal teams continued monitoring for spacecraft health and planetary protection purposes. the Extended Observational Network. Beyond the immediate Mars orbital assets, the European Space Agency's JUICE spacecraft attempted observations during its outbound cruise phase.
I mean, and what if it was all planned? Like, what if they planned all that? So, but why would they even tease us and let us know that something even coming? Yeah, that's crazy.
In early November, although the geometric configuration was less favorable and the spacecraft's instruments were optimized for distant, faint targets, any data collected would contribute to tracking the comet's activity as it rounded the sun. However, the extensive downlink queue meant that public release of any JUICE observations would not occur until early 2026. This distributed network of observational assets formed a comprehensive layered approach, with each mission contributing unique fields of view and spectral ranges. The staggered nature of data releases and complex interagency coordination ensured that the scientific story would unfold gradually, with each dataset potentially providing crucial clues to understanding this mysterious visitor. Surface detection from another world. Perhaps the most remarkable aspect of the entire observational campaign involved potential detection from the Martian surface itself. NASA's Perseverance rover, operating in Jezero Crater, conducted a 9-minute sky survey sequence on October 2nd using its right Mastcam-Z instrument. Each captured frame contained precise UTC timestamps and embedded metadata, including exposure time, filter selection, and camera orientation parameters. The imaging sequence, originally designed for routine sky surveys, captured something extraordinary, a faint streak cutting across the stellar background that neither aligned with known satellites nor matched the characteristic motion of planets. This potential detection represented what could become the first direct observation of an interstellar object from the surface of another planet. The analysis process began with rigorous calibration procedures. Raw images underwent standard processing, including flat fielding, dark subtraction, and bad pixel correction. Every potential artifact, cosmic ray impact, and optical ghost reflection required investigation and...
The crazy thing is, what if it really is aliens? Like, if it really is aliens, we don't know what to do, because we don't know if the aliens is coming to kill or if they coming to chill. You know what I'm saying? But we hope y'all coming to chill, aliens. You know what I'm saying?
Elimination before the streak could be considered genuine. The Mastcam-Z calibration workflow, familiar to the instrument team, involved comparing sky background levels, checking radiance units, and precisely aligning multiple frames. Astrometric analysis followed calibration, utilizing NASA's SPICE kernels to translate the rover's pointing direction into precise sky coordinates. The predicted path of 3I/Atlas, derived from JPL's ephemeris calculations, was overlaid onto the image stack for comparison. Measurements of the streak's angular velocity and direction showed remarkable consistency with the comet's projected motion as viewed from Jezero Crater during that specific time frame. Photometric analysis revealed that while the streak remained faint, it persisted consistently across multiple frames. Its measured brightness aligned with theoretical predictions for a diffuse, rapidly moving coma at Mars's distance from the visitor. The light curve showed no spikes or sudden variations that would indicate camera malfunctions or atmospheric interference. The final verification step involved fitting the observed streak position against the predicted ephemeris. Residual differences between expected and observed positions fell within several arcseconds, well within acceptable error margins for this type of measurement. However, official confirmation awaited review from NASA's instrument leadership team, a process delayed by the ongoing government shutdown. The interstellar visitor.
Damn.
Ground-based observations conducted.
They keep saying government shutdowns prevent stuff, y'all. I just hope y'all paying attention to what's going on. You know what I'm saying?
Before Earth's observational blackout revealed extraordinary characteristics that distinguished 3I/Atlas from typical solar system comets. The final clear images, captured from Namibian observatories on September 25th, showed an emerald-colored coma extending nearly 700,000 kilometers across space, approaching twice the distance between Earth and its moon. The distinctive green coloration resulted from sunlight filtering through clouds of diatomic carbon and other exotic gases, creating an almost artificial appearance unlike typical cometary emissions. However, the structural morphology proved even more unusual than the coloration. Instead of displaying the classic elongated dust-tail characteristic of textbook comets, 3I/Atlas exhibited a pronounced sunward anti-tail, forming a wedge-shaped feature pointing toward rather than away from the sun. This anti-tail formation, composed of large, slowly moving particles influenced by the peculiar geometry of the object's interstellar trajectory, created an appearance more reminiscent of a drifting fan than a conventional conventional comet streak. Additional fainter shell and arc-like structures rippled outward from the nucleus, suggesting episodic rather than continuous material ejection processes. Subsequent imaging attempts on September 27th and October 2nd, though hampered by increasing solar glare and reduced signal quality, confirmed the persistence of these unusual structural features. The coma boundaries maintained their distinctive shape even as overall brightness diminished, resisting the smearing and elongation effects typically expected from dust-driven tail formation. Anomalous physical properties. The numerical parameters describing 3I/Atlas defied conventional comet classification systems. Its velocity through the solar system reached nearly 60 kilometers per second during the Mars encounter, with theoretical models projecting acceleration to 68 kilometers per second at perihelion.
It looked like a big fat blunt is what it looked like, riding straight through the sky, straight through space. Big fat blunt, you know what I'm saying?
Passage. These speeds significantly exceeded typical long-period comets, which generally approach at 20 to 30 kilometers per second. The trajectory characteristics proved equally puzzling. Rather than approaching from a steep, randomly oriented angle typical of interstellar visitors, 3I/Atlas maintained an orbital inclination of only a few degrees relative to the ecliptic plane. This alignment with the solar system's primary orbital plane represented a statistically rare configuration for genuine interstellar objects, which typically arrive from high inclination trajectories. Size estimates based on brightness measurements and coma modeling indicated a nucleus diameter of at least 5 kilometers, potentially larger. This scale placed the object among the largest interstellar bodies ever observed, comparable to 2I/Borisov and dramatically exceeding 1I/Oumuamua's dimensions. However, the surrounding coma structure presented even greater mysteries. Polarization studies revealed concentric shells or arc-like features, each reflecting light with subtly different characteristics. The absence of a conventional filamentous dust tail, replaced by a massive structured envelope, challenged fundamental assumptions about comet physics and material ejection processes. Resilience against solar weather. September 25th delivered an unexpected natural experiment when a coronal mass ejection, a massive eruption of charged particles and magnetic fields from the sun, struck 3I/Atlas directly. Space weather forecasters tracked the CME's progress through interplanetary space, predicting significant interactions with the comet's extended atmosphere. Typical comets respond dramatically to such solar particle bombardments, often exhibiting rapid outgassing, ion tail formation, and visible morphological changes within hours. Scientists anticipated observing shock fronts, ionized gas emissions, or structural distortions as the energetic plasma encountered the comet's coma. However, the actual response proved remarkably subdued. Post-impact observations from both ground-based facilities and Mars-based instruments revealed minimal structural changes. The characteristic green halo maintained its crisp appearance, the anti-tail preserved its wedge-like morphology, and the outer shells showed no evidence of sudden expansion or fragmentation. The absence of typical ion tail formation
And that like a damn missile or something headed towards us. So yeah, that's scary. Yeah, that's it. Goodness.
or dramatic brightening puzzled plasma physicists who expected clear signatures of magnetic turbulence and enhanced ionization. This unexpected resilience raised fundamental questions about the object's internal composition and structural integrity. The lack of obvious plasma interactions suggested either unusually resistant surface materials or internal structures that somehow buffered against solar weather effects. Scientific classification challenges. The confirmed hyperbolic trajectory of 3I/Atlas established its interstellar origin beyond doubt, placing it alongside only two previously identified visitors, 1I/Oumuamua and 2I/Borisov. However, the certainty of its extrasolar origin represented merely the beginning of deeper classification challenges. Some researchers favored traditional comet terminology, citing the green coma, evidence of outgassing, and layered envelope structure as supporting conventional interpretation. Others expressed skepticism, pointing to the absent dust tail, persistent anti-tail configuration, remarkably stable structural features, and mechanical-appearing velocity profile as evidence against standard cometary classification. This debate transcended simple nomenclature, reflecting fundamental questions about evidence standards and the burden of proof for extraordinary claims. The scientific community's experience with 1I/Oumuamua provided cautionary lessons about the dangers of premature speculation. Initial observations spawned numerous theoretical models and hypotheses, but only the most rigorously supported interpretations survived subsequent.
We had one person significantly change their telomere length within 4 days.
Scrutiny. data access, and community engagement. The unfolding scientific story of 3I/Atlas created unprecedented opportunities for community participation in real-time astronomical research. Multiple public data streams provided access to raw observations and preliminary analyses as they became available from various international missions. Primary data sources included the European Space Agency's Planetary Science Archive, the UAE's Mars Mission Data Center, and various National Space Agency repositories. These platforms typically released quick-look images and preliminary spectra as FITS files, often accompanied by browse-quality JPEG images for broader accessibility. Independent analyst communities, including specialized mailing lists and Comet observation databases, provided rapid cross-referencing and verification services. When new observations or potential anomalies appeared, these networks quickly compared findings with ephemeris predictions from JPL Horizons and other authoritative sources. Community-driven analysis proved particularly valuable during periods when official channels faced delays due to governmental shutdowns or data embargo policies. Independent researchers often published comparative image stacks, photometric analyses, and orbital fitting results within hours of raw data availability, especially when official verification processes experienced disruptions. The continuing mystery. As 3I/Atlas completed its closest approach to Mars and began its journey towards solar perihelion,
So this right here is what's basically going on right now, the continuing mystery of it all, you know what I'm saying? They know what they know, but this right here, they don't know.
Fundamental questions about its nature remained unresolved. The confirmed interstellar origin stood as the only undisputed fact, while virtually every other aspect of the object challenged existing theoretical frameworks. The true chemical composition, the mechanisms responsible for its layered coma structure, and the absence of conventional dust-tail formation all demanded explanation. The object's surprising resilience against coronal mass ejection, impact suggested internal properties or surface characteristics unlike any previously studied comet. The staggered release schedule for observational data from multiple international missions ensured that the scientific story would continue evolving over months or years. Some results would emerge within days, while others required extensive calibration and validation processes extending into 2026. Each new dataset carried the potential to resolve existing puzzles or introduce entirely new mystery. The case of 3I/Atlas demonstrated both the power and limitations of modern astronomical capabilities. Despite humanity's extensive network of space-based and ground-based observatories, cosmic geometry and political circumstances could still create critical observational gaps. The reliance on Mars-based assets for this encounter highlighted the importance of distributed observational networks and international cooperation in space science. As data analysis continues and new observations become available, 3I/Atlas remains a testament to the universe's capacity for surprise. This interstellar visitor, with its emerald glow and defiant anti-tail, serves as a reminder that even our most sophisticated models and expectations can be challenged by the reality of cosmic phenomena. The full story of this remarkable object will unfold gradually, each new measurement and spectrum contributing to our understanding of these rare messengers from beyond our solar system's boundary. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.
Yeah, so as y'all can see, this thing got an emerald glow, and that's my birthstone. So you know what I'm saying. That's my cousin or something. But yeah, man, we got aliens coming towards us, man. Gonna be here soon. It look like they see something, but they don't know much. You know what I'm saying? They don't know what the hell this is coming at us, man. But they do see something coming at us, and I just hope they don't make any rash decisions. You know what I'm saying? Like trying to shoot at the shit or something before they even know what it is. And you know what I'm saying? The thing be way more powerful than us, and you know what I'm saying? Destroy the earth or something. You know what I'm saying? But we shall see, man. I think a lot coming up for November with the 3I/Atlas, with more stuff they're gonna be able to visualize as the thing gets closer or whatever the path that it's going on. So we got to stay tuned, man. We got to stay up to date, see what's going on. You know what I'm saying? Let us fool us out there. You know what I'm saying? Them aliens might be already landed or something. You know what I'm talking about? But make sure y'all do what you do. Hit that like button. Subscribe. You know what I'm saying? I'm gonna try to bring y'all more of these videos, man. I'm gonna for sure try to stay up to date with this 3I/Atlas, because it's a crazy situation. And as far as the markets, I know the market's taking a little dump. I told y'all I'm gonna help y'all get that money too. You know what I'm saying? So as far as crypto, buy Bitcoin. Holla at y'all on the next. Yeah.